And I can see we are live, so I would like to welcome to this webinar arranged by the BS Group. It is the second voyage efficiency for CII compliance that we're having. And it's sponsored today by DeepSea. It's sponsored by DTN, NAVTOR, and VesOPS. And you can see the lineup of speakers here. What we'll do is that we'll each present our topic for around 15 minutes. There's a Q&A section where you can ask some questions, and we'll try to answer them as good as we can during the presentations. But in the end, we will also have a Q&A section, so wherever all presenters are present, and feel free to ask questions during that session also. But I think we will start with the first presentation, and that's by me. So I'll give you an introduction on. I'll try to share my screen. So I'll give you an introduction on more the status of EEXI and CII and where are we, because a lot happened since the last time we had a webinar. So I'll just try to give a status on that. So I'll share my screen and share my presentation. So I hope everybody can see that one. So the content of my presentation will be something about EEXI. I know that it hasn't got a lot to do with CII, but even though it has a little to do with CII, because the power limitations that you put on engines to comply with EEXI might affect also your CII. Then something about the engine power limitation or the Sharply, whatever you choose, the status of the CII, some very few CII cases, and something about why the CII isn't the right indicator for this, and then an outlook on where this will take us. So my name is Soren Vinther Hansen. I'm the director in VesOPS. What we do in VesOPS is that we do performance monitoring and analysis for our clients in the shipping industry. So we do data logging, we prefer sensor data, high frequency data, we do a digital twin of the vessel, and then we analyze the performance, give some operational decision support, KPIs, and help the owner to optimize the operations, and thereby also optimize the fuel economy, but also optimize the CO2 emissions, which affects the CII. So generally, we have a package, software package that we offer the owners, and they can sign up with a vessel or a number of vessels if they want. If in fact, we have been doing a lot of EEXI assessments also for owners, and of course, it ends up in there's a required EEXI, and you want to know, okay, do I comply to the required EEXI? Or what can I do to get to the required EEXI? So there's a lot of things you can investigate, and there are two methods to do this. There's the statistical method, which is not so good for you if you have a good vessel. And then there's the method where you go in and look specifically on the vessel, the speed power curves and the SFOCs, and then you get an attained EEDI that's as close as possible to the required EEXI. And here I put dig deep for the information on the side of the slide, because here it really pays off to find the speed trials, to find the model tests, to get hold of whatever information you can get about the engines, because the statistical values, if you evaluate it by those, then you get a penalty. So if you have the information where you can use the speed power curves or the model test, then that will definitely get your vessel better out in the end of the calculation. Anyway, when you finish calculating the EEXI, then you probably find out you have to do some power limitation on your engine. You can do it also by power limitation on your shaft, and then you can also try to install some energy saving devices to make your speed performance better. or you can convert to a low carbon fuel if that is possible for you, which is in many cases it isn't. But that's also a possibility to get better EXI. Then you have to, if you go for improving the energy efficiency, then you can fit some energy saving devices, some ducts, bus caffeine or whatever you can find. Apply a better anti-fouling paint in dry dock. You can do some hull modifications, and then you have to document the efficiency after the improvement, typically by a speed trial. And I just wanted to highlight that on the last MEPC, IMO issued this in-service speed trial document, the Circular 901, where it's described how you do in-service speed trial. If you don't have an original speed trial from when your vessel was new, you can do the in-service speed trials at 2 conditions and then get the EXI speed power curve, which, if you do a lot of retrofits on your vessel and do a lot of improvements, could be a good alternative to you to get a better EXI assessment. So that's an interesting case to look at. But of course, if you then reduce your engine or your shaft power, then of course you also reduce your speed. So when you come with your MCR limb on your main engine, then you get a V limb, and that's the maximum speed that you can run with this vessel. Of course, in many cases, it is within the range of the market speeds, because the market speeds are lower and lower. So if you fit your vessel into the market that you're operating it in already, then it's no problem for you. And you have the ability to override the limitations if you have a case of emergency. But you also have to look if your limitations are too high, the value of the ship in the market. And then what is it that you can do with this vessel? And some are just reduced too much to be able to operate in any market, and then you have to scrap them. So that's something to consider. And you have a while to consider it yet, because generally you have to do it within time frame of 2023. I put derating and new propeller. I think it's an overseen thing. If you derate your engine already and then put a new propeller on, I think you'll get much more value out of the EXI assessment if you do that. Then if we go to the CII is accepted as the indicator in the market. I see investors are using it already. Insurance companies are using it. Chartering companies will probably also use it, and other stakeholders from the industry will look at it, because it's easy to understand. I mean, A to E, very easy. Some colors, green and red, everybody understands it. And the question is it then something that give the right image of the vessel? Because it has been evaluated across the industry over the last half year, and in general it's agreed that it's not the best indicator, due to let's say the factor that it's so dependent on the operational profile, not so much on the energy efficiency of the vessel, but more on the profile of the vessel. And we see a lot of solutions available. We have a solution also, of course, and then predictions is a key. I'll talk a little bit about how to predict it for future, for the future. And then we still need to see the clinch in between owners and operators and charters, because the charter might operate the vessel as he normally used to, but that might be bad for the CII, and he has no responsibility over to the CII. So it's the owner's problem when the charter is finished using the vessel. And I think that there needs to be some good guidelines for that, and I think that's something that's being worked on right now. And then, of course, no CII without exemptions. So a lot of exemptions are already agreed on. So if you have high electrical consumption, high boiler consumption, if you're a shuttle tanker, if you run in ice or safe navigation, then you are allowed to deduct the fuel oil consumption that you use for those special operations. And I don't think we have seen the end of those exemptions, but some are already agreed on. And I think you should go into the rules and see which ones are the ones that you can use in the future for your vessels. here's an example that it pays as 7 vessels, so it pays to have an energy efficient vessel, because if we look at vessel 1 and 2 in 2019, they are in the sea area, and then they are dry docked, and then they are baited, and then they go to the A area with the same operational profile as 2019. It improves down to A, and the same for vessel 4 and vessel 5. They are also dry docked, so they go from B to very low A. So if you can maintain the profile that you have, it pays off to maintain your vessel. Here's an example of maintenance. It doesn't matter because we have some vessels, 7 vessels again, and then we see the last 2 vessels, they jump from B to C to E, or from A to D. And if you look at the operational profile on the right, then you see that the 2 vessels, they have very long idling periods and very few hours at sea. And then you're penalized on your CII. You can have a very efficient vessel, but the profile is the one that decides which CII you have. So that's why we don't like it so much, because it doesn't always say anything about the fuel efficiency of the vessel or the energy efficiency of the vessel. So you can make a simulator or prediction. I think we'll see some presentations including this, but you will need to know the factors that affect the CII, and that's the operational profile, and that's the actual state of the vessel. So is it fouled a lot? Has it just been dry docked? And what's the actual energy efficiency of the vessel? So if you can say something about those and say, okay, the coming year, the factors will be like this and that, then you can simulate what is the NCII when I come to the end of the year. And then a small outlook, because of course you cannot forget the SEMP Part 3, because the SEMP Part 3 says something about CII. You have to target set your CIIs for the coming 3 years. You have to state how you calculate your CII, and you also, if you are a E-rated vessel, then you have to give, let's say, an idea of how do you want to get out of rating E, because you're only allowed to be there for 1 year. And you have to state that in your SEMP Part 3. So there's some work to be done on that. I know it's already ongoing. I think the final rules came out in MEPC 78, so people are working on that already now. So are we, in fact. In 2026, we have to see this is going to be revised. So all the experiences that have been gathered from 2023 to 2026 will be revised by IMO. And then we will see how it's going to be in the future. Because this is like towards 2030, like a midterm improvement of the shipping industry. And then what I think is interesting is what happens with the E-rated vessel, because if you're sailing in a specific area with specific cargo that has to go to that area, then you might have a certain operational profile, and then you always rated E, even though you have a very good vessel. So what happens with the E-rated vessels? I think that's going to be interesting. And then how do you log the factors for exemptions? There's a lot of factors that are not logged already. So you have to set up some logging schemes, but also some verification schemes from class. So then have an idea of whatever you give them is the right thing. I know the current CII is already under revision. So there's talk about splitting the CII, a propulsion CII, and then a consumption CII in general. Because the propulsion CII will say more about the energy efficiency of a vessel than the way the CII is done right now. And then, of course, it is interesting to see if there is an increase in percentage of improvements toward 2030, because I guess requirements could be a little bit more strict, and probably they will, or maybe they will. We don't know yet. And a small commercial for my little company: if you are in doubt of what to do, please come and see us. We have the system. We know how to log. We know how to do performance or monitoring analysis. So we are an option among many options, and you will see some of them today. Thank you for your attention, and then I think we will go to. And then I would like to invite Angus Whiston to the floor. Angus.
Thank you, Soren. Can you see my screen?
I can see your screen. Please present yourself, and let's hear what interesting things you have to say.
Thank you very much. Hi, everybody. I am Angus, and I'm the Communications Director at DeepSea. It's a real pleasure to be able to talk to you all today, especially amongst such a lineup of esteemed speakers. I think here you've got the great and the good of the voyage planning and optimization world. So I hope that it's going to be a very interesting couple of days for you all. I know that it certainly is for me. So I'm going to speak to you about performance routing. And, you know, I think that right now, this space that we're all talking about, the voyage optimization, voyage planning space, is so hot and so exciting and developing so fast. And where we come in as DeepSea is we realized a couple of years ago that if you take weather routing and you take AI and put them together in a certain way, you have the most incredible decarbonization tool. My goal for today is to communicate three things to you. The first thing is what performance routing is. The second thing is how it's done. And then the third and most important thing is what it does for you and your fleet. Now, the thing is, I'm going to give you the answers to each of those questions in the next 2 minutes, and then we're going to go back and deep dive into what those answers really mean. So at least bear with me for 3 minutes. So weather routing as a concept does what it sounds like, right? We all know. We create a route and sometimes a speed plan for the weather. Makes sense. Performance routing, similarly, makes sense. We create a route and a speed plan for the vessel performance in the weather. And what we're all here for today is to work out how to make every vessel as efficient as it can be. And by being more efficient means it burns less fuel. And by burning less fuel, it means it requires less energy to get from A to B. And in order to do that, we have to understand what the energy requirement at every step along a voyage is. That's what performance routing is. How do we do that? Well, we use AI to work exactly that out. And here's the thing that everyone's been waiting for. What does it mean for you? What's the impact of this? It's actually very simple. It's about 10%. So that's about 10% more efficient when it's well deployed for every one of your vessels. In context, what that means is +1 CII grade. For a mid-sized fleet, we're happily talking in the tens of millions of dollars per year. And just before I crack on, I'm sure the question that you're all asking me now is, Angus, you are describing a miracle tool. If it is what you say it is, why isn't everybody adopting it? And I'm very pleased to say that they are. So some of you may have seen last week, we announced our most recent partnership with Wallenius Wilhelmsen, who have decided to roll a performance routing approach out across all of their 120 vessels. And much more news to come as we announce more partnerships over the coming months and years. That's everything I'm going to say. I'm now going to say all of it, but in a much more understandable way. I'm going to dive deep into what this really means. So, optimization means getting everything right. It doesn't mean guesswork. You have to get everything right. So what does this mean for us? Well, if you don't understand the energy profile of a vessel in the weather, then maybe we'll say, okay, you know what, let's take a slightly longer route to avoid the nasty winds that are coming in. Okay, that makes sense. You've improved your voyage by 3% in terms of the fuel consumption. Great. But did you know that you also missed the currents that would have pushed the vessel along in a nice way? By avoiding those, you've actually made a negative 3% change to your voyage efficiency. And they cancel each other out. At the end of all of that, we didn't get everything right. We got half of the things right, and the impact is 0. You have to get everything right. Because, guys, we're not talking 50% here. We're not talking 80% savings or 90% savings. We're talking about 10%. That 10% comes from getting everything right. And just one sort of statistic to leave you with here. Some research that we did recently told us that for some voyages, a 1 to 2% inaccuracy in the modeling of the vessel can lead to a 10 to 15% higher fuel consumption on some routes. That's all a bit theoretical. Let's take this down to a real life example. Here is a voyage that we optimized in September 2021. This voyage already had an existing route plan. We just used performance routing to optimize the speed profile along this voyage. Now, the interesting thing about this voyage is this. At the beginning of the voyage, you can see that there are strong winds with the vessel, but the currents are against the vessel. Then they flip around. The currents become with the vessel, and the wind becomes against the vessel. And then they flip again. The wind goes with the vessel, the currents go against the vessel. What do we do? In order to save that 10%, we have to get everything right. I'm going to introduce now probably the most important concept in the whole of performance routing, which is every vessel is different. You know that every vessel is different. Even sister ships will have different fouling statuses. They might well have quite different machinery setups. There's all sorts of stuff that's going on there. In order to make everything right, you need every vessel to be understood independently. What we do is we take your data from the vessel, and then we use artificial intelligence to very efficiently model that vessel with 19 parameters, including the obvious ones like wind and currents and wind angle and current angle and draft and fouling and all of those other things that go into your vessel performance. And we use those models to answer the question that we've just posed. Here is an example of a wind model that we have created, or should I say more specifically, this is a visualization of one aspect of the model with several parameters being varied. So let's just stop it here. This is MV Sunshine. It's a fictional vessel, but it's a specific vessel. It's a tanker, and we've fixed some parameters. This is going 12 knots. It's got an even keel draft of 9 meters. And what we can see here is the wind speed, the apparent angle of the wind, and the energy required to travel at 12 knots in those conditions. And let's interrogate it a bit. So, for example, we can see, because we know the model, here we go, at a wind angle of precisely 82 degrees with a wind speed of precisely 24 knots, the energy required is 13 kilowatts. And we can see that for all of these different condition sets. Brilliant, makes sense. That's 1/2 of the answer to that question that we've just looked at. What is the optimal speed profile for this voyage? Of course, you can probably guess what the other half of the question is. Here's a current model. So again, everything's the same. We're going 12 knots in this tanker, even keel, 9 meters. We've fixed all those parameters so that we can show you this. And now we've got exactly the same thing. It's just that instead of wind, we're talking currents. So let's investigate again. Let's say at one point in this voyage, we know that the current is 1 knot here, and the current angle is about 100 degrees. Okay, we know that the energy required just from that factor is 11 kilowatts. Brilliant. We've got the information that we need to be able to optimize this voyage that we're talking about. Now, of course, on this one, you can see this is only for visualizing the currents that are against the vessel. You would also have a similar model, which is sort of a reflection for when the currents are with the vessel, because that's also very important. Okay, so where are we now? We've used AI to model an individual vessel so that we can tell in any set of conditions, including the varying draft and the varying speed and all of that stuff, exactly what the energy requirement is going to be. And ultimately, lowest energy requirement means lowest fuel. But we haven't talked about one very important thing here, which is fouling. In this graph that I'm showing you now, you can see the same vessel. The blue lines are the vessel when it's clean, and the pink lines are the vessel when it's foul. This is mission critical knowledge, and of course this is changing through time. Our artificial intelligence picks up on this and moves that model as the fouling develops, percentage by percentage, because it's critical to this optimization question. Why is it so critical to the optimization question? Well, it's because it's non-linear. I guess most of you out there probably know what that means. But if it was linear, what we could say is fouling develops, it doesn't change very much. We just know there's going to be a higher fuel consumption at the end. It's not the case. Let's have a look at this clean vessel. In the dotted line on the blue, you can see the clean vessel in currents. So the difference between the currents and the no currents is this gap here. Okay. Let's look at the foul vessel. There's a much higher deviation, as in the currents make a much bigger difference. We all know it intuitively, but you need to know specifically at what speed. Let's put this into a real life example. So we're traveling through a section of currents and we're traveling 12 knots and we know what the excess energy required is going to be. Well, if it's a fouled vessel, it's going to be way more. At that point, you say, okay, maybe we should change the route, or maybe we should change the speed so that we change the currents. All of this factors in. It's vital knowledge when we're talking about getting everything right. What does all of this mean in the end? Well, here we have simulated along that voyage that we talked about 2 different conclusions, one of which is when the vessel is clean, and the one of which is the vessel when it is fouled. And as you can see, so here we have the speed through water is pink. Here on the clean vessel, you can see that it follows the winds much more because it's not as affected by the currents, and therefore it is tracking the wind speed and the wind angle and the impact of the wind. That's what makes a difference. That's what lowers the fuel. With a fouled vessel, you can see it's almost the exact opposite. It's following the currents. It follows the currents because it's the currents that contribute the majority of the resistance and therefore the excess energy to actually optimize this voyage. Now, in reality, of course, it was somewhere in between because the vessel that we actually optimized for is neither fully clean nor fully fouled. It's somewhere in between. When we took this approach on that particular voyage, it led to a 7.8% efficiency improvement. And hopefully you can see now exactly why and how that happens. That is performance routing in a nutshell. I'm going to end in a second, but just to give you some next steps, if you're interested, there's 2 things that I'd encourage you to do. One is, this is really fascinating technology, and it really is a silver bullet for decarbonization. It is the low-hanging fruit that we here encourage everyone to, it's the step that we encourage everyone to take as step 1 on their decarbonization strategy. Get in contact with us, go onto our website. We'd love to give you a 15-minute overview of this technology, how it actually works. And by the end of that, we'll have some idea together as to whether this kind of approach would work on your fleet. But if you're not ready for that quite yet, go onto our website. We are hosting a webinar alongside Wallenius Wilhelmsen in about 2 weeks' time, where we're going to talk not really about our technology. We're not going to try and sell anything. What we're going to do is lift the lid on the implementation process about what it actually takes to deploy this kind of solution on your fleet. There's one final thing that I have to say, given the context of this chat, which is performance routing an alternative to weather routing? It can be. You now know the methodology and why that can be a very successful option. But at the same time, with a number of our partners, we very successfully work with established weather routing providers who have a trusted relationship within that organization. We model the vessels, we create the speed plans, and that in itself, just that one step, can make an 8% improvement to your voyage efficiency. I think I'm done, so I'll be around until the end. Anyone who has any questions, do stick them in the chat, or we can chat afterwards. Ping me on LinkedIn or anything else. Thank you very much.
Thank you very much, Angus. Very interesting. A lot of percentages from your system. I like that. So I just have one question. So the AI model, so you need a lot of data to create the AI model, right? So how do you do, is it like you have a large chunk of data where you will model from, or how is that set up?
Great question. Yeah. So actually, the way that you raise a very good problem, which is you generally need a lot of data to make AI work. We use a very special kind of artificial intelligence, which effectively means we take knowledge from ships in general, and then we tailor it to the specific vessel. Because whilst every vessel is different, two vessels are much more similar than, let's say, a vessel and a rubber duck. And so we use that knowledge, exploit it, which means that, to answer your question, about 3 months of data is what we need.
Okay. 3 months of high-frequency data.
High-frequency data, and if you don't have high-frequency data, we certainly still encourage people to get in contact, because there's some very interesting developments around that.
Right. Very good. Thank you very much. Stick around. There'll be some questions for you in the end, I think. Then I would like to introduce the next presenter. That's Stavros Meidanis. I hope I pronounced that right.
Yes.
He's the manager and director of the Capital Executive Ship Management Corporation. And please go ahead, Stavros.
Thank you very much, Soren. Let me share my screen. And sorry. You can see my screen?
Yes.
You can see my screen? Yes.
And the presentation, yes.
Okay, fantastic. So thank you very much. Good afternoon to all attendees and our colleagues that we are in the same panel. I'm Stavros Meidanis, the Managing Director of Capital Executive Ship Management. I will try to give a little bit the other side of the challenges that we have to face as operators of the vessels, and I believe that it will be linked from what we just heard up to now and the next presentation. Just a couple of things about our company. We are the dry segment, the dry company of the Capital Group. Currently, we operate 40 vessels, 36 container vessels, and 4 bulk carriers, Cape size. And the majority of our fleet is under the NASDAQ-listed mother company, Capital Product Partners. Of course, we have the vision, and in our days, the most important thing is to promote the safety culture and utilizing new technologies, which is very, very important in order to achieve the goals, but also of what we have in front of us. And I'm coming to what our governing body, IMO, has set us main targets towards decarbonization. So all of us, we are quite familiar that we have to cut the carbon emissions up to 40% by 2030 and 70% by 2050. This is the goals. This is the targets set by IMO, and we have to see what we're going to do and how we're going to achieve that. We have short and medium terms measures. We heard in the beginning on Soren's presentation that, as we know, the CII compliance, we are start reporting 1st of January 2023, and in 2026, the whole scheme will be revisited in order to see if any adjustments are required. So we have also the long-term measures and actions that we're going to discuss again, as I said, from the side of the ship operator. Very briefly, we have in front of us the new IMO regulations, the CII, the XI, the decarbonization strategies that we have to face. On the other hand, we have the installations, the shore facilities. We have to see how this is going to be connected between. We have the different types of fuels. I'm coming to that very soon, which is again related to our overall voyage efficiency performance, the zero emissions with different ways, and don't forget that we have discussions about green corridors, lanes for zero carbon emissions, and so on and so forth. So, main challenges in front of us, very briefly, at that point, we're talking about a global marine fleet. When we're talking about a global marine fleet, the global marine fleet right now is approximately 52,000 vessels worldwide. Is that in simple figures? 2.6 billion tons. Those vessels should comply with the new regulations that we have in front of us starting 1st of January 2023 and to achieve the IMO targets. We have the speed. All of us, we know the relations between the speed and the consumption. Just to give you an example, if we have a 10% reduction in speed, this easily could lead us to have approximately 27% decrease in power demand, which is we have to take into consideration. Then we come into cost. It's very, for all of us, when we are talking about cost, we are talking about fuel price, and again, we're talking about consumption. So, speed, consumption, fuel price, it's quite related to all this. And the last but not least challenge, from my point of view, is the split incentive issue that we have, which is again related to cost. I'm not talking from something different. We need investments in order on board the vessels, retrofit, or during the new building phase for new buildings, in order to be able to comply with the new regulations and to have efficiency on board our vessels during the management of those vessels. Yes, but on the other hand, we have to consider this cost if it's going to be split between, for example, charter, premium rates. There's a lot of discussion about that. That's why we're talking about split incentive issue, something which is for the owner, for the ownership is very, very important, especially when we're talking about the new building assets. I'm coming to short-term technology measures. Ship and propeller design measures. I'm not going to expand on that. I would be very happy to, if possible, to reply to any questions at the end. But ship and propeller design measures that we could take right now could lead to a greenhouse reduction 5 to 10% based on the studies that we have in our hands. On the other hand, for example, the alternative power assisted technologies, all of us were aware about flutter rotors, towing kite sails, solar panels. All those kinds of technologies could lead to a reduction, greenhouse reduction, to 12%. On the other side, we have also the operational and voyage optimization measures. We heard up to now a couple of things, and I'm sure that the rest of my esteemed colleagues will continue to their presentation as well. We discussed about slow steaming, advanced port logistics, automation, IT tools development, or energy design. All those measures could lead to a 5 up to 30% reduction to greenhouse gas reduction. From only that slide, which is described that very, very briefly, we can see that we have a variety of options in front of us, and actually we are not sure about the effectiveness of each measure, for the simple reason that most of them we have, it's quite new, or we have in a study, as a study. So owners are confused, or I would say they're not so optimistic what will be the best solution and measure to take in order to cope and reply to these new challenges. On the other hand, we have the fuels, the alternative fuels. Again, very briefly, we have two main categories, as we know: the drop-in and the alternative. The drop-in fuels, we are already starting from 2020, we have already implemented such kind of approach, blended fuels without engine modification in our vessels, only minor modification, I would say. On the other hand, we have the alternative fuels. I'm not going for sure to which one is not my purpose, but just to give you again an idea, if we're talking about LNG is already here, it's already used, and could be, I'm not sure, but it could be the alternative fuel until the final decision that our industry will take. If we're talking about ammonia, for example, we have some barriers, I would say, about the production, the price, the supply. If we are discussing about hydrogen, with the main question is that we have very low volumetric density, or even if we're talking about nuclear propulsion in the military, in naval military vessels, they are used to for years now, especially submarines. But this is not something that we are sure that we can effectively, efficiently, safely implement aboard a commercial vessel. As far as it concerns the availability of measures for the decarbonization 2030-2035, as a mid-years up to 2050, we have three types of measures already recognized. We have the technological measures, we have the operational measures, and of course, as we discussed, the alternative fuel and energy measures. Right now, if we say very briefly about the technology, we have lighter materials for vessels, and I'm talking about the new buildings. We have hull coatings or propeller ducts that technologically we can consider as measures, air lubrication for less friction, or even energy recovery mechanisms for waste heat recovery. On the other hand, operationally, lower speed, ship size, shipboard interface. we have to be very careful here, because if we're talking about lower speed in a market, we may need more vessels. This is always, there is a market-driven decision. On the other hand, we have ship size. If we have good utilization of the vessel, larger ships are lower emitted assets. On the other hand, what about the seaport interfaces? Do we have enough ports for bigger ships right now worldwide? Or even what about the facilities that the ports have in order to accommodate such kind of vessels? And finally, of course, we have the alternative fuels and energy, as I described very briefly in my previous slides. So again, propeller ducts, cold down ironing, scrubber system. Most of the vessels right now we are running on the scrubber, dual fuel, ammonia and the LNG fuels. Concluding, I would say that all of us, our industry, from all aspects that we can see, we are in a transitional phase. We are trying to understand, first of all, and try to understand and to try the best, I don't know, it will be the best solution at that time overall, but at that time we try to do, as we heard earlier, the optimum. On the other hand, we have to take into consideration that of what we have in front of us, the question should be not how, but when. And most probably the reply is now. We don't know the way to. The carbon pricing scheme has to be agreed. As I said earlier, financial incentives should be provided in order to share the cost, because at the end of the day, the new asset will be sky high due to the technology and the technology and innovation that will be included on board those vessels will be quite high. And of course, all interested parties should be involved in order to contribute effectively to that transition. I don't know if I cover this, and I'm okay with the time. Thank you very much for your attention. I would be very happy to reply to any questions. Yeah,
thank you very much for the presentation. That was very interesting. I just have one question before we go on. So, have you tried any of these medium-term incentives? Have you tried wind assisted propulsion, anything of that kind in your fleet? Is it something that has been tested?
Yes. Hear me, sorry. Can you?
I have problems hearing you. All right, I think we lost ours. We'll take that one later. So, thank you again to Stavros, and then we have from DTN, we have Jarco van den Brink, who's a shipping product manager at DTN.
Can you hear me now?
I think we lost Stavros.
Yeah.
Okay. So please, Jarco, go ahead with present yourself and then your presentation. Thank you.
Yeah, good day, everybody. I'm Jarco van den Brink, product manager at DTN, working for DTN for 16 years now. A background in meteorology, so I'm coming in from a meteorological angle. For the ones who don't know DTN, I'll give you a brief introduction of what DTN is doing. DTN has more than 30 years of experience in voyage optimization. And if you look at the product portfolio, they're really centered around these four competences, which is the onboard voyage optimization system called SPOS. We have, of course, shore-based routing and consultancy services, accurate weather data that we deliver, and we have turnkey APIs in our portfolio that you can easily integrate in your business application in the area of performance management, weather routing, weather optimized routing, and of course also some data science APIs. Yeah, also some logos of the companies who rely on DTN services. But let's start with the topic for today, which is of course centered around CII. So what I did, made a little bit of a strategic business planning for CII. So I actually created a SWOT analysis around CII, from my point of view at least, where we can look at the strengths, the weaknesses, the opportunities, and the threats. I think, Soren, you also mentioned some of the strengths of CII is that it's simple to understand. You don't need a master degree in mathematics to understand the calculations. And the labels, it's quite straightforward. So that's really a key strength of CII. And another strength is doesn't need any new data points. The typical Noon reports or the MRV DCS reports that are being done are sufficient in order to cover for the CII data. Moving on to the weaknesses, it's not always an incentive to reduce emissions. That's also a little bit highlighted previously, that in some point, especially with idling vessels, you don't do any mileage, which is a negative part for your CII rating. And then sometimes the captain might in the future decide to start slow steaming in order to make a few mileage, and well, the consequence is that you will burn some more CO2 emissions. So that's something that, well, time will tell, but that's some of the weaknesses that we can identify. And it's not an indication of ship performance. It's more the operational performance of the vessel. And so it's not a true indication of the ship performance. Well, moving on to the opportunities. Actually, one of the big opportunities is the weather optimized routing and the amplified effectiveness of that. And I will dive into that later on, so more on that to come. And then, of course, that it will expedite greener solutions. You can think of wind-assisted propulsion, like already mentioned in the previous deck, and new fuel types. Also threats. So unknown business impacts, not everything is settled in the whole CII domain. And one of the key things is that if you're unable to digitalize and basically staying compliant and anticipate on the changing markets, you will struggle. So the whole digitalization is important and as well. And if you don't do that, that could be a threat. So one of the common things to do on a SWOT analysis is to overlay it with a used strength you can use, weaknesses you need to stop, opportunities you need to exploit, and threats you need to defend. For CII, I would say the top ones are less relevant because those are regulatorily driven. The strengths and the weaknesses of CII are parts of the regulatorily parts. But for the opportunities and the threats, we can look on what is our use the opportunities and basically mitigate the threats that we see now. So one of the key things there is, like I already mentioned, the weather optimized routing or performance routing, how it's being called previously as well, while also, of course, continue to invest in long-term green initiatives. So that's a topic I want to dive into in this presentation first. But secondly, we also need to have a look on the data adoption of the company. So that will be the second topic I will address today. So let's zoom in into these topics. First one is the weather optimized routing. This might be a familiar image where a vessel is going from Houston to Rotterdam, where the black route is the shortest route, a great circle across the Northern Atlantic, where the green route is really the weather optimized route, making usage of the currents, the vessel profiles. You can see that it's clearly making advantage of the Gulf Stream off the coast of the US. So if we plot then the voyage details on it, then you can see that actually the weather optimized route is a longer route. It's 173 nautical miles longer than the shortest route. However, you will save time, save fuel, less CO2, and also save on costs. But what does that mean for CII? So somebody needs to bring up, of course, the Cii formula. This is a simplified version, of course, where you see actually that the fuel consumption is in the numerator at the top, and the distance travel is in the denominator at the bottom. And from the previous example that I mentioned, in the weather optimized routing, you have more mileage and less fuel consumption, meaning there is I would say an emphasized effectiveness of weather optimized routing. So you're basically benefiting on both sides of the equation here. So I think that's something I want to highlight, that weather optimized routing is an effective tool to stay compliant for CII due to the benefit that is on both sides of the divider. Moving on. So one of the things I wanted to show as well is the data adoption, like I mentioned. And that's all about making strategic decision within your company about the data adoption. And actually the maturity curve that I've presented here can help with that. You can plot your business processes on this maturity curve. And I'll actually have an example in a minute. The scale goes from passive to prescriptive, where passive basically means that you have no data that is being used in the decision-making process, so analog data that is being used. Then operative is that you have point solutions in place in order to solve your use cases, and the point solutions don't talk to each other. So that's basically the operative stage. In the cohesive stage, the data is integrated to serve multiple use cases, so you can see that the data is more and more integrated, whereas in the predictive stage, you have full data integration for your decision making. And then, of course, we have a little bit of a future stage where artificial intelligence is widely applied in order to make the strategic decisions. And well, you can plot your business processes on this. And yeah, that's where I have an example in a minute. And what I really want to emphasize is that if you want to move up in this maturity curve, you really need to cross-collaborate with domain experts and feed the data of those domain experts in your systems in order to move to stage 3, stage 4, stage 5. And you can also see that moving into the first stages upwards is easy, but it gets more and more difficult in the later stages. So let's have an example for routing. So here is a use case for routing. You can see that in the passive stage, going from A to B is being done by common routes or best practices. In the operative stage, weather routing is being used or shore-based routing services. Where in the cohesive stage, we have weather optimized routing or performance routing. In the predictive stage, things get more and more, I would say, connected, and then you need to think of just-in-time arrival, having bunker information being fed into the route optimization. But for example, also vessel motions, that you can keep your vessel safe, and all that in decision making and all those data points are being combined in order to come to a best route. And future case is, of course, that everything is connected and that we have a fully optimized supply chain. Well, in the whole sphere of the webinar, I also have an example of CII. So for CII, you can think of Noon report gathering in the passive stage, but in order to be compliant, you already need to be in the operative stage to use CII for compliancy. Cohesive, really used also for forward-looking use cases. Do I want to charter the vessel with a particular CII rating? What do I need to put in my charter party conditions? So that's more in the use cases in the cohesive stage. Predictive stage is, of course, if everything gets more and more intertwined and connected, and CII and emissions are an integrated part in the decision making, up to prescriptive, just like with weather routing, then it's fully optimized. So that's a little bit the utopia moving forward. So the whole, I would say, moving up in the maturity curve is not something specific for shipping. It's also happening in other market segments. You can think of the consolidation that happens in the whole ERP domain or in the online marketing, where actually we can learn from. So it's not something specific for shipping, the whole digitalization that's going on. Yeah, like I mentioned, if you want to move up, it's key that you have access to data, and the whole maturity goes hand in hand with the data adoption. The more mature you are on the scale, the more integrated data you have in your systems. If you look, for example, at the portfolio of DTN, I've plotted a few services that we offer on it. You can think of that weather data is applicable, I would say, in all stages. But if you are going to the operative stage, performance data and shore-based routing are getting important. Whereas if you move to the cohesive phase, the weather-optimized routing it gets important, and knowing about digital twins of vessels, and the more, I would say, data science related services for the predictive and the prescriptive phase. So, yeah, it's important to have a look and plot your business profiles on this maturity curve, and seek out to partners and domain experts in order to enhance your data set and really, I would say, make a roadmap on how to move up in your digitalization journey. Then just to recap on the key conclusions, yeah, like mentioned, CII, the whole domain is still subject to change, but like I explained, weather optimized routing, I would say, is a key part in order to mitigate risk, especially due to the amplified effectiveness that I showed you with the mileage and the less CO2 emissions. So it's really I would say, an effective tool in order to keep your CII under control. Yeah, then maybe a little bit of homework for all the audience is that take a few minutes to plot your business processes on the maturity curve and make a plan on how to move up, because and seek the alignment with domain experts like DTN to enhance your data portfolio. Because if you move up in the maturity curve, you will unlock additional values due to the data adoption, like I showed. So those are the key things I want to highlight and stipulate in this in my presentation. Thank you.
Thank you very much for the interesting presentation. So, do you see? So on the data side, going from noon data to sensor data, auto log data, is it moving faster? Are people going more into high frequency data monitoring, or how do you see it from your side?
Yeah, sure. So there are, of course, early adopters. Companies who are really at the forefront are really busy working on the sensor data and getting that to shore and doing all kind of analysis with it, AI. So yes, sure. There is also the other end of the spectrum where there's some market segments which are a little bit slower, and I think that's a natural thing. Like I mentioned, we can also learn from other industries, and what you see in the whole digitalization, that if you plot your business processes on such a maturity curve and at least make a plan on how to move forward and at least have that dot on the horizon, I think that's a really important step for companies.
Yeah. All right. Well, thank you very much for your presentation. We'll ask you some questions later on, I think, but please keep an eye on the Q&A. There's a lot of activity there, so you might get a question or two there. So the next presenter is Aaron Holton. He's the Vice President in NAVTOR. Welcome, Aaron.
Hey, Soren. Hi, everyone. Thanks for attending today. Sorry, I'm a little bit under the weather, so hopefully I make it through the next 15 minutes without a coughing attack. But as I said, just bear with me. A little bit about myself before I get started. As I said, I'm Aaron Holton. I'm the Vice President at NAVTOR. In my role, I support a range of strategic digitalization initiatives for the company through our e-navigation and particularly our performance portfolio. Previously, I was the CEO of Trace Solutions, which NAVTOR acquired in early 2021. And I spent the earlier part of my career as a management consultant with Charles River Associates and PacWest Consulting Partners, which was acquired by IHS Markit in 2014. So in my previous lifetime, I focused on a number of strategy projects in the big data and advanced analytics space. operations and implementation, commercial due diligence, and organizational development. So that's a little bit about me. I'll jump to the presentation now. Plan to talk today a little bit about the CII regulation or overview, but I think Soren and my other industry colleagues did a pretty good job of covering that. So just to save a little time, I think I'll skip ahead and then talk more through points 2, 3, and 4. So what are the key levers for improving vessel level CII rating, as well as some of the solutions that we at NAVTOR have for monitoring and predicting the CII. So like I said, I'll skip the kind of overview. Happy to answer any more detailed questions about that later on in the Q&A side of the presentation. So as I mentioned, for me, kind of at NAVTOR specifically focused more on the performance side, we always look at a number of different levers and then how we can support our customers for improving the CII rating. At the end of the day, like everyone said, at least the outputs of the A to E ratings are pretty easily understood. So we know our goal is to achieve a C rating or better. And if we look at the attained CII calculation, even with the newest changes post the June 2022 meeting, there are certain things that we know that we can control or at least influence in that formula. So a big thing that we always talk about with our customers is controlling the controllables. And so that's certainly relevant here. In the numerator, you have grams of CO2, which, as we discussed earlier, is essentially an emissions calculation. This is annual consumption and an emissions factor. So what is it that we can control here? Some of the levers were already touched upon, but really we look at these in terms of operational and commercial levers, which are the top part here. The middle area is some machinery, equipment, or technical levers that Stavros mentioned. Maybe we're less focused on at NAVTOR, but companies can certainly pull those levers in terms of machinery and equipment upgrades. And then you have the fuel side. So how do you impact that emissions factor with your fuel choices? In a bit, we'll walk through some very simple case studies in terms of how you can combine certain of these levers together to not only optimize the fuel performance of your ship, but obviously the environmental efficiency and thus the CII. I think as most people now know, speed can obviously have a really large impact on consumption. So we'll see how that can play out. When it comes to auxiliary consumption, we often see in the performance space, this is actually very low-hanging fruit. So both at sea and in port, where there's the ability to use shore power, you have the ability to influence your attained CII rating. Also on the main engine performance side, there are a number of different initiatives and kind of following best practices for maintenance can certainly improve efficiency of your vessels. And then, of course, with hull cleanings based on good information and kind of, I would say, reliable simulations, you can determine the best and the most optimal time to clean your hull to improve performance and thus your CII. And then I think as some of our other colleagues spoke about before, weather routing or performance-based routing certainly have a positive impact on your fuel consumption and of course your CII rating. And then on the machinery side, there's the potential for installation of energy-saving devices, hull form optimization, and even the choice of paints and coatings can certainly have a positive impact on the vessel's CII rating. And then the third area here is on the fuel side. There are a number of options. I think Stavros covered these very well.
Soren, can you hear me?
Yes, I can hear you.
Yes, Stavros. As soon as we're waiting to give some time for, again, to Aaron to connect, I heard earlier your question.
Yes.
But just to give some time to him. Yes, we are implementing a couple of numbers, I would say, of these measures, let's say, for both retrofit existing vessels, but also to our new buildings. So for the existing vessels, of course, about the new coatings and everything, but also we change the ducts, we change the bow of the vessel, especially to the Cape size vessels. For the new buildings, lubrication systems, all our new building containers are a dual fuel, but also ready for cold ironing, for A&P, I mean. So we are trying to find the optimum, as we said, as we discussed earlier. I don't know if it's the optimum, but we have some results in front of us, tangible, I would say.
Okay. Yeah, because I think what we see is that the companies that are well prepared, they have seen, okay, for my existing fleet, I need to do something not to lose too much power on my EEXI assessment, right? So it is a good thing, both for the ability to operate with the speed that you would need to operate in the market, but also, of course, to cut emissions. So it's a benefit, no matter one or the other, both for the business, but also for meeting the regulations. Do we have any? Excuse me, I'm just continuing. Do you have any experiences on wind-assisted propulsion in any of your vessels, or is not a technology that you have tested? It didn't go through. Okay. I think we will. While we're waiting for Aaron, what about you, Elias? Would you? Are you up for a presentation?
I will be happy to.
Okay.
Thank you, Soren.
Then we'll switch. We'll switch to Elias Holmsløkke, which is the performance master mariner in Torm. Please go ahead, Elias.
Thank you very much, Soren. So I'll just see if it works. Give me a second. Here we go. I hope you see my screen.
Fantastic, we see it.
So just 2 words about my background. First of all, thank you for inviting me to this very interesting session. So I've headed up, besides from being a master mariner, I've been at sea, so headed up energy efficiency departments, heading up performance departments, and now I head up the routing department in order to sort of improve the maturity level of Torm's weather routing and voyage optimization. Before I move on, so Torm is a tanker company. We have about 80 vessels, all tankers, LRs, MRs, not the smaller ones and not the really big ones. We have everything in-house. It means that we have technical management, we have commercial and operational management, we have finance, we have business intelligence, we have all in-house, which we consider as a major advantage on our side. In Torm, we also have a technical decarbonization who does all the very, very exciting and interesting things about testing paint types, hull cleaning, retrofit projects, innovation projects. We also have a commercial decarbonization team who's looking into everything under the commercial hat, which is the charter parties, which is everything we can do under the new CII regulations and whatever comes into the future. And then we have the operational decarbonization team, which is me, looking into weather routing and voyage optimization. This presentation for me will not be about CII. I am of the opinion that we're not ready yet. We still need to see the effects in real life, and we still need to understand better in real life what the effects and what the impacts are of the CII before I think we're ready to share it. And I would think many other shipping companies are of the same opinion. So a little bit like Jarco mentioned regarding maturity curves, that's also where we started off. We built our strategy some 4 years ago, and we're actually following our strategy. The idea is that we want to have everything digital. We want to have monitoring and guidance being sent out from our computers, from our systems. We wish to use our BI sources and integrate it with high data quality. We try to work with many different companies, and I'll get into that in a little moment. We would very much like also to do cradle to cradle on everything we do. So from before the voyage starts until after it has been executed, to better understand where we can improve and learn from practices from the industry and adapt it into our system. Where we are today is we have spent I almost say 3 years in analyzing all the estimates, looking into pre-voyage, also generating dashboards and improving our weather routing and voyage planning and creating dashboards and improve our two-way communication. Soren has actually been part of a project in the shipping lab project where we improved two-way data back and forth to our vessels. We have in the same project looked into added wave resistance because that's a very, very large part. I think Angus from DeepSea also mentioned about that you need to have the data in order to improve your optimization. One fundamental thing we have kept in TORM is we actually use DTN's SPOS tool. We have decided to do that and continue to do that because we would like our seafarers to be the ones who make the decision at first hand. Then I can, on top of that, develop a lot of things and give them my best advice, which is not arriving from me, it's arriving from an AI or from a data-generated system. On top of that, we also do make use of DTN's routing service, case by case, not continuously, because vessels, they do have SPOS and they very much like to use it. So that's sort of the starting point in everything we do. I try to make, and I apologize if it's a little busy, I try to make a sort of a data flow chart on where we get data from and to and where and who. So everything everything starts from our vessels. So a captain would start up a voyage and we would gather the data. We would gather the SPOS data from DTN. We would also get AIS data that we get in from Polestar. We also have all our commercial data sources, which is in our case, it's Whiston. They deliver IMAs. We also work together with an AI-based company called OV. It's a short for Optimum Voyage. I will get into that in a little second. Every data fields we have, we put into our business intelligence, and we use advanced analytics to create alerts, to create notices, to create AI-based optimized routes, and to inform all our internal stakeholders. Could be safety, it could be vessel management, it could be routing, myself, it could be our operators, and obviously the most important one, which we should never forget, which is the people on board, of course, the vessels. We have heard something about high frequency data. We are not entirely there yet. We are there for about 8 of our vessels, so it's also in progress. We can see some benefits. It's too soon to say too much because we're still learning from it, and we still need to adapt high frequency data into our network. But it's getting there. On the shore side, we use DTN's products to visualize for the operational and technical and safe teams. We use their fleet guard system to visualize any effect from bad weather. All the data that you see on this screen will also be on our servers so that we, as an example, can look ahead in time. We can simulate ahead in time. We can simulate the effects of a bad weather system. We can warn about a navigation area. We can set up warnings and triggers. We use it a lot for cyclones, which we consider quite dangerous, or extreme seas or high seas or icebergs. So that's how we notify and how we use the data, so that we push notifications to our seafarers on anything that they find relevant and that I find relevant, and obviously also that others find relevant. We shouldn't overflow our seafarers and only push relevant messages. But now we have done it for a little over 2 years, and it actually has a significant effect that you can 7 days within the forecast period look up a captain's route and also use his AIS data to identify where a vessel is relatively to something unwanted. Let's say a cyclone developing, or let's say an extreme area, or let's say a iceberg warning. And it works. The effects are, I'll go into that in a little while, because we're trying to measure it. We're not experts in that, but I'm sure that we can get better in that area. But we are trying to measure some of the effects that we try to implement. Next part is the AI. This is a company called Optimum Voyage. So we source in data, we submit data to their servers, and we receive data from their servers, and that data we then push out to the vessels. So we try to we have already automated it. We have done it for about a year. I think we are about 20,000 routings we have already sent out to our vessel fleet since January 1st. We do it daily, so the algorithms, they work in the behind. We can work in 2 segments, so we can, since we're a tanker company, we work in charter parties, so we're restricted to the charter parties. But the AI is obviously developed to follow those restrictions that we have. So we cannot do everything, and we are still a tanker company. We'll still have to follow whatever is stated in the contract. So of course we do that. We do see a lot of benefits by it, though. How it works, and Angus from DeepSea also sort of touched upon that. I'll see if it works. I hope the simulation works. Yeah. So it works with waves. It works with currents. It works with swell, and it works with wind. So we have spent, as mentioned earlier, quite some years in analyzing the effects on one of our vessels, many of our vessels, from each area. What will the effect be with 1, 2, 3, 4 meters from right direction, and what will be the effects be from the wind or from the swell, and obviously from the currents. That's not difficult to predict. Our AI then has all these informations available, and it simulates it in real time, and it will send it out to the captain in real time for him to consider. We do not push it as an order. That we would never do. We push it to the captain for his consideration, so that he's capable of, via the SPOS application, actually, to simulate both the proposed route and his own route, in order to see if there are any parameters that he can use in his own route and then adapt it. On top of this, we also in our operational or commercial execution, we run in we call it constant power. It means that we try to benefit from running the most efficient way of using the engines on board. I'm aware that many modern companies, they would think of this as something all shipping companies in the world would do, but I can guarantee you that they don't. And it has actually proven quite some cost savings. We have seen especially in bad weather, up to 2 tons per day on a standard MR type, and in average we save somewhere between 0.5 and 1.0 tons per day. And sailing activities for a tanker is about 180 days. So it's actually a significant amount of money we can save by implementing something as simple as constant power concept throughout our entire fleet. The last, and I think I'm well on time, the last slide I brought is a little bit about the benefits. I mean, can we track it? And obviously that goes to the CII. In our business intelligence system, we have AIS positions for all our fleet. On average, we get 48 signals per day. So meaning that we have roughly every 30 minutes. We then glue it to the, as Jarco mentioned, they have a service where you can, via their API, get access to the world weather. So we glue our AIS positions to the world weather, and then we can track the performance of our vessels. And we then also, together with this sort of KPI that we implemented to all our operational staff, where we wanted to change the behavior, we also set a hard target to avoid more than 7 meters of sea on our vessels. In practical terms, it's above 8, but the alarms are triggered at above 7. So those two KPIs we implemented together with the alerts and together with the AI. And what we have actually been able to track, we began on January 1st, 2020. We have seen a reduction in the number of times we hit more than 3 meter seas at 7%, which I consider quite significant, because that's both in terms of safety, but it's also in terms of fuel consumption, because obviously if you are able to change the route and avoid the bad weather, you avoid the overconsumption on that route. I know that you most likely take a longer route, but in total, what we can see is that you save more by avoiding the bad weather. We have also been able to, and we can see that on our tracking, but we don't have that many years of data yet. Since we started in 2020, we only have 2 heavy weather seasons, but we can see that the heavy seasons are reduced, meaning that the number of days or times or AISs with the weather where we hit bad weather in the weather season are less. It's too early to conclude something, but we do see a reduction. Most important, actually, what we have seen is the number of heavy weather incidents, where we in the past had registered in average between 10 to 12 heavy weather incidents per year. And for those who does not know, one heavy weather incident has the cost of around $100,000 because of bended steel or things that needs to be replaced on the deck, which is a safety hazard. And we have actually, for one consecutive year now, had exactly 0. And we believe that that's because of the proactive way of approaching a captain and informing him what he can avoid in the future, and obviously to follow up and escalate in case it's not happening. That brought me to the last slide. So thank you. I think I'm well within time.
Fine, Elias. Thank you very much. Very interesting. I must say I am impressed how you managed to collect data from so many tools. I mean, so I would imagine that if you could have a tool that could include everything, right? It would be, but you managed to use the tools that the different businesses are using, and then integrate it into one system.
Yeah, and it's not easy, but because some of them talk different languages. But we have actually managed to, our management is very supportive in this direction, and they wish us to be very digital. So adding resources to our business intelligence team has taken a little while, but we are there now, and we're very, very happy about it. And it proves out very well, because we now have, you also know VPS, so we also have their data in our BI system, and we can actually have both performance data, meaning updated fuel curves, meaning everything together with the weather data and the AIS, and now the AIs combined in one repository system, so that we can extract it and use it proactively.
Fantastic. It sounds good. Good numbers also on savings and incidents avoidance. So thank you very much, Elias. If you'll just hang on a while yet, I think we got Aaron back. So Aaron, do you want to continue from where you left?
Yeah, I have no idea where I left off though, so I'm hoping you can guide me.
You were at the slide with the CIIs and the arrow up and down, and how the CII was calculated.
Oh wow! Okay.
I think that was the last one we saw.
I was talking for a really long time then without knowing. Okay.
We didn't hear you.
Hopefully okay. We can get back on track. So
that's fine. that one. Exactly.
Can you let me know how far I got down this path of showing the different levers?
I think you went to weather routing and then I lost you.
Gotcha. Okay. Yeah. So just kind of picking back up where we left off. So kind of with weather routing and the kind of performance routing, as my colleagues were talking about earlier, those are kind of the operational or commercial levers that can be pulled. And then, as I think Stavros and Soren both walked through some interesting optionality on the machinery side. So the potential for installation of energy saving devices, whole form optimization, or your choice of even your whole paints and coatings can positively impact the CII. And then on the fuel side, again, won't rehash what was discussed, but there are obviously a number of options here, and I think we could debate all day the technical feasibility and the commercialization of these different fuel types. I think LNG would probably be considered today one of the more proven on this list, although we know there are other environmental drawbacks around methane slip. And so I think we're seeing a lot of our customers look to more biofuels or drop-in fuels, which have positive potential. And then, of course, on the longer term side of things, looking at renewables and other alternative fuels like ammonia and hydrogen may have a very positive impact in this development. And then these are the things that you can do to impact the emissions coming from the vessel. Looking at the denominator here, the distance part of the equation, this is where more commercial or market-driven decisions around vessel utilization have an impact. So the simple way to think about this is the more time you spend at sea, obviously controlling other factors around speed, you can positively impact your CII, whereas a lot of time spent idling can adversely impact your rating, where you're emitting CO2 but not covering any distance. And so we see a lot of our tanker and bulker customers who spend quite a bit of time in idling, at least 50%. And so, of course, this has a large impact on the CII rating as it's calculated today. I'll kind of go through a couple of case studies here. Keep in mind, these are pretty simplistic, and there are a lot of factors that go into these calculations. But if we take an MR tanker from our universe that's around 50,000 deadweight tons, sailing at an average speed of 12.5 knots, spending 50% of her time at sea, then we can run a scenario on distance covered over the calendar year, as well as CO2 emissions, and of course the CII score for that vessel. And so kind of tying back into the previous slide, we can look at it here at a couple of the different operational and commercial levers, at least, that can influence your CII rating, starting with speed. So this first scenario, we look at the operational commercial lever of speed reduction. So in this scenario, we're envisaging a 10% speed reduction where the vessel is moving the same distance as the base case. So here the vessel would sail at an average speed of 11.3 knots. And because they are reducing speed, they're spending more time at sea to cover the same distance. In this case, there was a resultant reduction in CO2 emissions. And then with this reduction in emissions, they can improve the vessel's CII score from the base case. In another scenario, we look at a 10% speed reduction again, but instead of covering the same distance, in this case, we were looking at the same time spent at sea. So here, 50% of the vessel's time spent at sea. And the result of this is that she covers less distance. So here you can see the drop in distance covered. And so in this scenario, there's a commercial or revenue implication here, which could be very negative for a shipping company. And this is where I think a lot of the debate comes off as an operational measure with competing commercial interests. So in this case, the impact on consumption, CO2, and your CII is a net positive. So you're improving your CII rating. But this situation, as I said, creates a revenue or a commercial trade-off that will certainly be debated, particularly in a market where day rates are high and you're incentivized to go faster and spend more time at sea. There's also a scenario where you're spending 10% additional time at sea. And so at the same speed, so this is an example of a commercial or a market-driven action where the vessel is trading over greater distances. In this case, the vessel would operate at the same speed as a base case of 12.5 knots. But instead of 50% of time at sea, the vessel is now spending 60% of her time, thus covering more distance. Interesting thing is, in reality, this creates more emissions on an absolute and percent basis, but because they're spending less time idling, they're still able to improve the CI by about 3.5%. And then and kind of last lever here that we'll talk about, as we mentioned earlier, one of the levers is reducing auxiliary engine consumption. So looking at the possibilities here for basic load reduction. And so in this scenario where you're able to reduce basic load by 10%, but then operate at the same speed and spend the same amount of time at sea, you can see here that you're still covering the same distance. But because you're optimizing basic load, you're still able to reduce consumption and also CO2 emissions, which has a positive impact on your CII. Less so than, say, a speed reduction, but still positive. And so, again, these are pretty simplistic visualizations here, but you can see that speed is quite a good lever, probably the best lever here from the things that we typically look at, where, and of course, this is where market conditions allow it to be able to reduce the vessel CII. And then combining these speed reduction levers with, say, basic load reduction, which is not uncommon and certainly possible. You can see how you can positively impact a vessel CII. So with this in mind, and as we talk about the levers coming from the performance side of NAVTOR, how do we help customers achieve their CII targets? I think when we take a more consultative approach to how we support our customers, it comes with, number one, understanding their current situation and then where they are today. And then two, ultimately outlining what actions that you as a shipping company can take in order to help you achieve your goals and objectives. And so for those of you that don't really know NAVTOR, just wanted to provide a little bit of an overview of the company. We were founded in 2011. Our headquarters are in Egersund, Norway. We have more than 150 employees today, spread over 11 countries globally, and a large number of distributors worldwide. Our services and solutions are deployed on more than 8,000 vessels today, with customers in more than 60 countries, representing nearly every vessel segment. The genesis of our company is in the e-navigation side, and that's what people certainly probably know us most for. But we have been continuously expanding our portfolio. And really the vision here is to offer a total ship operations platform with the ultimate goal to help companies become more sustainable and efficient in their operations. And so we've rapidly evolved and are continuously adding new services and solutions to our portfolio to help customers address some of their key pain points and really be a one-stop shop for a lot of their operational, commercial, and technical needs. The right-hand side here, you can see our digital ecosystem visualized. As I said, it's constantly expanding, and our goal here is to continue to provide more integrated solutions that really provide a seamless experience, not only from ship to shore, but also among other stakeholders in the industry. So I think a big part of any of the regulations here, whether it be CII or other environmental related regulations, I think being able to create greater transparency is key to being able to progress as an industry. And so it's a very important part of what we do. And we believe that by creating a single source of truth, we were able to help kind of facilitate the objectives of the industry and our customers. So I'll kind of go through a couple of different tools that are effective, and really, I think these achieve some of the objectives that we talked about quite well. But in general, I think as you start to think about how you can move your CII rating in the right direction, having some of these basic tenets in place are really important to being able to create greater visibility into what your CII rating is. But again, more importantly, back to the levers, how do you start to influence these things in a positive way? So We have a Voyage Planner in our nav fleet tool. This helps operators understand how speed impacts voyage CII. So with this, we have an integrated voyage calculation, and we have a series of our own vessel-specific performance models that help us accurately predict things like voyage costs, emissions, consumptions, and CII rating. So you can think of this as a pre-fixture planning tool that operators can use to enter in a voyage itinerary. So in this tool, operators are able to enter in arrival information, departure port, time, draft, and other voyage instructions, such as avoiding eco zones, piracy areas, or block areas like the Panama or the Suez. And then the system will then calculate the distance between the 2 points and then any distance spent in eco zones based on the most commonly sailed routes between point A and point B. And then you also have the ability to input fuel prices here to kind of drive cost calculations as well. And so with this information, the system will then run a series of simulations based on the existing propulsion efficiency of the ship. So important here again is understanding the true picture of your vessel. So if your vessel has a fouled hull or is performing suboptimally, it's important that all of your simulations take that into account and are not running kind of generic database models here. And so the system will again run scenarios of this vessel at different speed profiles. And so you get eco speed simulations, full speed, slow steaming, and even manual speed instructions. So the ability to kind of select something that may be an alternative to the others. And at these speeds, the module will calculate total voyage consumption, emissions, fuel spend, and again, tying into our discussion today, we'll predict the CII from that voyage. So from berth to berth, what is a predicted CII attain score, the letter rating, and then also looking at the change to the vessel's CII over a 12-month period. And so we can, of course, look at this on an individual voyage level, but then also understanding the broad impacts on your vessel are important and allows you to make better decisions in terms of nominating the right vessels for the voyage, not based only on commercial interest, but also from a compliance perspective. We also have a fleet dashboard here. This allows users to view individual status for individual vessels, sister class, or a fleet at a simple glance. And so here you can get an easy kind of overview of the vessel's CII rating from A to E. And so the bar plots kind of can give you in a hover over that rating. And then these bar plots can be easily expanded. And with this, you can see kind of more near-term trends. So taking the 90-day moving average to see a more recent CII development for the vessel, and then period average, which over the past year, you can see what is the attained CII rating. And then through hover over functions, of course, not just understanding where you are today, but then what is the gap between your attained CI and the required CI, so you know how far you have to go. And then again, going back to the levers that we discussed, know what kind of you can do to help achieve a better rating for the vessels. And then we also have ongoing tools for voyage analysis that allow users to look at current or historic voyages, either on an overall voyage basis or based on specific voyage legs. And so with this, users are able to see a lot of critical environmental information, such as total CO2 emissions, the CII rating for a particular voyage, as well as the attained score. And so it's helpful in that regard, so you can constantly monitor the environmental performance of your vessels, but then also these kind of tools help you to also understand other things around voyage execution, charter party performance, and then other key efficiency metrics. I think any pretty analytics is only so good as the data coming into it. And so I think for us, one of the things that we really pride ourselves on is flexibility and how we choose to deploy modules. Soren asked about this earlier in terms of different ways of data collection. And so we just released a new, very simple CII reporting tool that allows you to collect enough information just to understand the CII rating for your vessel. But the nice thing about our NAVFleet tool is it can be scaled up or down based on your objectives. So it can be as simple as whether or not you want to just look at your CII rating. Are you looking for more EU MRV or IMO DCS compliance, or are you looking for a full-scale performance program where more detailed data capture is really important? And then having flexibility in that approach, we're starting to see a bigger push for more and more automation in data capture and analysis. And so the ability to deploy fully manual reporting up to fully automated reporting that auto-populates noon reports based on sensor data is, I think, a big benefit of our toolkit. And then having a robust data validation system in place certainly can help. So we have a number of vessel-specific validations built into the reporting forms itself. And then we have a performance team of all kind of experienced engineers and captains that are monitoring these reports around the clock to provide instant feedback to vessels and to make sure that we get the data right. Because again, the analysis that follows should be based on really high confident data. And then finally, the ability to kind of seamlessly share data with other systems and stakeholders. As I mentioned, transparency and data sharing has, since I've been in this industry, have always been a little bit tight, a tight lid on it. So people, different stakeholders or different service providers are always reluctant to share information with others. We don't really ascribe to that approach. So the ability for us to push and pull data to other sources is really critical. Are you helping provide that single source of truth, but you're also simplifying workflows for seafarers who, since the pandemic and with all of these other regulations, are increasingly overburdened with a lot of different responsibilities aboard the vessels. So the more that we can automate the data capture and then the dissemination of that data to your pool partners, to your charterers, to your weather providers, or routers, to your technical managers, we have been able to do that, including kind of a recent integration with DNV, where we're able to push data to help support EU on an automated basis, which helps support EU MRV and IMO DCS compliance, as well as even helping satisfy a lot of the financing obligations for debt instruments that are tied to EEOI. So that's kind of everything in a fire hose. I think we're needed to probably jump to Q&A, so I'll just skip the takeaways. I think at the end of the day, we all agree that if you take data from vessels from 2019, it's generally understood that about 35% of the existing fleet won't meet the IMO's target of a C rating by 2023. So I think all of us here have talked about different things that companies can do to improve the CII, including real-time examples from owners. So these are a lot of operational, commercial, and technical levers. And I think for us at NAVTOR, we have a lot of these tools on the performance side that can bring greater visibility to your rating, but also help you make better decisions about what to do to improve that rating. So thanks very much for your time. Sorry for the technical difficulties, and hope you found it useful. I'll keep an eye on the Q&A, but feel free to reach out and would love to talk more about this topic anytime.
Thank you, Aaron. Interesting presentation. So you mentioned your team of performance experts. So they go back to the crew if there's anything wrong with the data. How was it? Do you have connection to the crew?
Yes. So typically, most of our forms have several hundred vessel-specific validations in place. So during an onboarding phase, we'll collect a lot of vessel-specific technical documents around sea trial data, shop test records, general arrangement plans, capacity plans, etc. But then as these reports are submitted, our teams we have our own internal dashboards that are reviewing this on a consistent basis and trying to understand where there may be additional follow-up required. So a big part of what we do is understand our owner preferences. So one, there could be data follow-ups, but also owners who have particular concerns about charter party compliance, maybe vessel stoppages, so just inefficient operations, or maybe running more auxiliary engines at sea than are required. We typically understand those things during the onboarding process, and then our follow-ups are geared towards that. So there's a direct conversation between us and the vessels that enable that to happen on a more real-time basis, which is particularly helpful where performance teams are kind of slim at shipping companies where they don't have enough people to be able to follow up on a regular basis.
All right. Interesting. So do you have a dashboard for the crew, or is it an office tool that you have?
Both. So on the crew side, they have a crew dashboard. And so that dashboard provides kind of ongoing and trend analysis for some key performance indicators. So not only looking at things like CO2 emissions and CII, which are providing feedback on an ongoing basis, but then also other things around hull fouling, speed management, SFOC, and other things that we believe in the way that we developed the system, that it is important to empower the crews to make better decisions without shoreside intervention. So the things that, again, that they could control without having to have somebody from the shoreside follow up. So there's crew dashboards, and then each 24-hour period, there's an analysis of, say, a typical sea report, where we compare reported data against models, and then again, provide instant suggestions about how to improve the performance of the vessel. And then, of course, we have a pretty large suite of shoreside BI tools above and beyond what crews have access to.
All right, thank you. So we have a few minutes left. I would like to ask a question out in the open. So feel free to answer. So this CII, is it the right measure to reduce CO2 emissions? I mean, it's easy to understand. Everybody knows what an A is, just like when you buy a refrigerator, it can be A, it could be E, depending on the consumption. But do you have any opinions on this, the CII, and continuing with that towards 2030? Will it improve or reduce the CO2 emissions from shipping or not? It's a big question. Anyone?
I can maybe start, and then somebody can jump in. I mean, I think that, and you mentioned this earlier, Soren, and I think we've discussed this before, that I think there are some limitations in the way that CIs, even the calculation method today, let alone the incentives that it provides. So from a calculation perspective, I think we believe that EEOI may be better, just because it's accounting for transportation work. That would be better than the current framework, and then it could deter non-intended behaviors from shipping companies. We've been at conferences where companies said that they were considering kind of just making sure their vessels were always moving, even if there was no particular trade or cargo on board, just to kind of positively impact the CI rating, which has a negative impact on emissions. But again, you can influence your rating in that way. And I think also the nature of the rating is commercially, it's very complex, because I think vessel on time charter could be traded inefficiently, and then it's returned to the owner with an inferior rating, which puts the owner at a commercial disadvantage following the charter. So I think that those are tough conversations, and when we speak with our owners, it's difficult for them to be able to manage. I know that I read that BIMCO was supposed to be publishing a CI time charter clause wording in the next couple of months. So hopefully it will address that in some way. But I think that it really challenges the trading patterns of vessels to try to force yourself to achieve a required rating. So I think these things are going to certainly have to be explored, and things will have to change, I think, to be more fair and balanced for both charterer and owner.
Anyone else?
Yeah, I agree with Aaron, right? I think that's the point, that's spot on, right? And the time will tell, right? So there are a few loopholes, like I also mentioned in the presentation. I think Soren, you also mentioned a few, right? So that's something where we need to account for moving forward. For sure, there will be some adjustments made, and it's also on the penalties, right? On what penalties are being associated with it eventually.
All right. So you're service providers, and two of you are representatives of owners. So how important is the CII? Because now I can calculate CII. I love to calculate stuff. I can predict. I put it in the software. Is anyone asking for it? Are you asking for it when you're looking for a system on the owner side? Is it something that has high attention? Or is it just us that see a new business opportunity as a service provider?
It has high attention, definitely. Luckily, we are in a position where we have the data to do it ourselves, but it is very, very high on our agenda. I also think that, but it's a personal comment, I think it'll be interesting to see where the shipping companies lie. I mean, where are they compared to the scale and the scalability? And the next thing is the obvious first movers will probably also go for the lowest hanging fruits to implement cleanings for their vessels, etc., etc., etc. So that I think there's a room for improvement, which is a very, very low hanging fruit. But again, we have to see where are the, I mean, we were surprised to see where we were because we were actually not very high on the scale. So we had, I think, one vessel we had to get rid of in order to be in compliance all over, which we are probably just lucky. So I mean, let's see how the world fleet looks like compared to to us first.
I think you're muted, Soren.
Yeah.
Sorry, I was talking a lot. So you service providers are people asking for this for your services? Is it high attention?
Well, there's a lot of fuss around it, right? So if you walk on the exhibition in Hamburg, for example, there's a lot of talk around CII. So it's a hot topic. Luckily, like Lai also mentioned, we have the data, at least for our portfolio in-house, so we can also apply because the calculations are easy. So it's an easy add-on that we can supply now.
Yeah, I think as you're saying, it's kind of because I think most service providers see this as the next greatest business opportunity, that there's so much discussion and so many releases around it. So I think maybe the bigger challenge is certainly customers are asking for it, but I would say on the other side of the coin, it becomes over time difficult because there's so many options available to understand what you're really looking at, and then which of the different solutions are really differentiated or can add value. Because again, the calculation itself is fairly straightforward, so it's easy to understand what your CII rating is. But then I think the next question's on what will it be in the future, and then how flexible is that solution, allowing you to run different simulations and kind of what if scenarios. And then at the end of the day, the so what question. Okay, well, I see my rating, so what am I going to do about it? And how scared are you really of, as Jarco mentioned, what are the repercussions if I don't comply? I think there's still probably skepticism of what's going to happen to me if I'm not compliant. And there's kind of quite a bit of time to be able to improve it. So maybe we're still haven't gotten to the point where everybody's fully on board and taking it 100% serious.
Yes, I guess we don't see it before in 2025, right? Because that's 2023. Then you get your rating. Then it's 2024 to improve your rating. And then if you haven't improved, then in 2025, we know what's going to happen.
Exactly. Yeah.
All right. So we'll look forward to see that. But unfortunately, our time is up. Thank you very much for coming and presenting. It was very interesting. I would like to thank you, BS Group, for organizing this. And of course, the sponsors, DTN, NAVTOR, and DeepSea, for sponsoring this. And me, of course. And then for the two owners, operators perspective, it's always very interesting to see how you handle the different challenges that are in the shipping industry. So thank you very much. And thank you for attending to all the attendees. Thank you.
Thank you very much.
Thank you.
Thank you. All the best.
Thank you.